And liftoff. Liftoff of Falcon Heavy with Europa Clipper.
They said it couldn't be done. They said it was too complex, too risky, too much ambition for a company that had nearly gone bankrupt. A rocket made from 3 reused boosters, stitched together with sheer engineering grit, wasn't just meant to fly. It was meant to rewrite space history. When Falcon Heavy finally ignited on February 6, 2018, it didn't just launch a red Tesla Roadster into deep space. It launched a new era, one where rockets were reusable. Space wasn't only for governments, and private companies didn't just join the space race, they changed its trajectory. With 3 boosters and 27 Merlin engines generating over 5 million pounds of thrust, Falcon Heavy became the most powerful operational rocket since the Saturn V. But what made it truly historic wasn't just the numbers, it was the idea behind it, fueled by failure, risk, and one radical mission, that SpaceX could challenge everything we thought we knew about spaceflight. It was equal parts engineering marvel and cultural spectacle. But behind the smoke and spectacle lies a story most people missed. A story of failures, brinkmanship, internal sabotage, and a CEO who once said SpaceX had a 10% chance of surviving. This isn't just about Falcon Heavy. It's about the rise of the world's most audacious space company. It's about how one rocket lit the match that would ignite a new space age. This is the untold story of Falcon Heavy and how it changed space forever. To understand why Falcon Heavy mattered so much, we need to go back, not to 2018, but to the moment when SpaceX almost didn't survive at all. Long before it became the most powerful rocket on Earth, Falcon Heavy existed only as an idea, scribbled in a startup's notebook. In 2002, Elon Musk had a vision: make humanity multiplanetary, starting with a cheap, reliable way to get there. But at the time, SpaceX was barely surviving, and the dream began with something far more fragile, a rocket called Falcon 1. Falcon 1, their first rocket, failed, then failed again and again. By 2008, SpaceX had burned through nearly all its funding. One last shot was all that remained, and somehow, it worked. The lifeline gave birth to Falcon 9, a rocket that was cheaper than legacy rockets, modular, and eventually reusable. It started flying missions to orbit by 2010. By 2012, it had delivered a payload to the International Space Station. But Musk wasn't done, because he wasn't building rockets just to launch satellites. He was building leverage. Fast forward to 2011, he dropped the bombshell, a rocket made from 3 Falcon 9 cores bolted together. Falcon Heavy would lift more than what the space shuttle could and cost a fraction of the price. The world watched. The industry scoffed. Building Falcon Heavy proved harder than expected. It wasn't supposed to take this long, as it was originally scheduled for 2013, but that didn't happen. Structurally, it was 3 rockets acting as one, with forces SpaceX's software and hardware had never handled. Even Musk later admitted it was way harder than we thought. Designs were torn apart, entire booster configurations were scrapped, schedules slipped. Critics began to call it vaporware. But behind closed doors, something else was happening. Each Falcon 9 landing brought new confidence. Each recovered booster was a rehearsal for what was coming next. And in early 2018, after nearly 7 years of delays, it was finally ready. Only this time, SpaceX wasn't just launching a rocket, it was staging a spectacle. On February 6, 2018, at Kennedy Space Center, specifically Launch Pad 39A, the same pad that launched Apollo 11, now it stood ready for another first. Falcon Heavy, towering at 70 meters, weighing over 1,400 tons when fully fueled. On board, it was not a sensor, but a midnight cherry red Tesla Roadster and a mannequin in a SpaceX suit they called Starman. The logic was simple. If the rocket blew up, as many expected, it wouldn't take an expensive satellite with it. But this was also pure SpaceX theater, and they don't do ordinary. At 3:45 p.m. ET, the countdown hit 0. 27 Merlin engines roared to life, generating 5 million pounds of thrust, the most since the Saturn V. The ground trembled. Car alarms went off miles away, As it soared, everything hinged on what came next: booster separation and recovery. Just over 2 minutes into flight, both side boosters detached cleanly and performed a synchronized boost-back burn. Minutes later, they landed in unison at Cape Canaveral, side by side. It looked like CGI, but it was real. The center core wasn't as lucky. It missed the drone ship and crashed into the Atlantic at 300 miles per hour. But even that couldn't overshadow what SpaceX had just pulled off. Then came the moment that sealed it. The fairings separated, and out floated the Roadster. Above Earth, Starman sat behind the wheel. Bowie's Life on Mars playing on repeat. Cameras beaming it all back live. It wasn't just a test, it was theater. It was confidence. And it worked. Falcon Heavy had launched and the whole world watched. But if Falcon Heavy was a triumph of engineering, what did it actually mean for spaceflight and for SpaceX's future? Falcon Heavy wasn't just a rocket test. In one launch, SpaceX sent a message. It could do what no other private company and few nations had done before. But what exactly did this rocket change? First, it shattered cost expectations. Traditional heavy-lift rockets, like the Delta IV Heavy, could cost upwards of $400 million per launch. Falcon Heavy promised to do the same job for under $100 million because its boosters could be reused. And then there's the power. With 5 million pounds of thrust at liftoff, Falcon Heavy became the most powerful operational rocket on Earth. Not since the Saturn V have we seen anything like it. But what truly made it revolutionary wasn't its raw force, it was flexibility. Falcon Heavy could lift 64 metric tons to low Earth orbit. That's nearly the weight of a loaded 737 passenger jet into space. It could send payloads to the Moon, Mars, or beyond. And because of its 3-booster design, missions could scale up or down based on need. It also changed how space was marketed. The launch became a viral event. Millions watched live. SpaceX didn't just build rockets. They made them cool. The Roadster, floating in space, became an icon. It symbolized not just exploration, but imagination. And behind the scenes, it forced competitors to rethink everything. Boeing's SLS was still on the ground. ULA scrambled to justify its pricing. Even NASA quietly reevaluated which rockets would carry which payloads. Falcon Heavy didn't just deliver a car to space, it carried a message. The future of heavy lift no longer belonged to governments alone. It belonged to whoever could fly smarter, cheaper, and more often. But if Falcon Heavy redefined private spaceflight, then why did SpaceX stop talking about it? And what rocket did they bet on next? After its debut, you'd expect Falcon Heavy to become SpaceX's flagship, but something strange happened. SpaceX rarely talked about it again. Falcon Heavy didn't become SpaceX's flagship. It didn't launch astronauts, nor did it become the go-to rocket for deep space. Instead, it went quiet. Why? The answer wasn't failure. It was its design, because Falcon Heavy was never meant to be the endgame. It was a bridge. Yes, it was powerful, but it was also complicated. Each launch meant coordinating 3 cores, 27 engines, and complex booster landings. That drove up preparation time and risk. Customers, especially government clients, would prefer simpler, more predictable missions. So SpaceX doubled down on Falcon 9, their proven workhorse. Fewer engines, cheaper launches, faster turnaround. While Falcon Heavy was spectacular, Falcon 9 was efficient. Meanwhile, Musk was already focused on the next leap. Starship, a rocket even bigger than Falcon Heavy, fully reusable, built for Mars. While the world marveled at Falcon Heavy, SpaceX was already building what came next. Falcon Heavy didn't disappear, it just became selective. It flew high-value defense payloads, launched NASA's Psyche mission to a metal-rich asteroid, served where Falcon 9 couldn't, and Starship wasn't ready. But in public, it was overshadowed because it was never the rocket Musk truly bet on. That title belongs to Starship, the one rocket aiming to replace them all. If Falcon Heavy was bold, Starship is outrageous. While Falcon Heavy was a monster by any standard, Starship is in a category of its own. Standing at 120 meters tall, it's the largest rocket ever built, taller than Saturn V, more thrust than SLS, and built to fly again and again. But Starship isn't just about size, it's about a complete redefinition of spaceflight. Falcon Heavy could lift about 64 metric tons to low Earth orbit, while Starship could do 150 tons, and it's fully reusable. In theory, it can refuel in orbit and go straight to Mars. No Earth return needed. Where Falcon Heavy relied on expendable side boosters and complex coordination, Starship is designed to be mass-produced like aircraft, made of stainless steel, built rapidly at Starbase, and tested at breakneck speed. The first orbital test flights were explosive, literally. But they weren't failures. Each one gathered terabytes of data. Each one brought Starship closer to operational. As Falcon Heavy stepped into the background, Starship took center stage. NASA selected it to land astronauts on the moon under Artemis 3. SpaceX pitched it for lunar cargo, and Musk still talks about Mars. Yet, what makes the shift most striking is what it says about Falcon Heavy. It was never the future. It was just proof that the future was possible. But SpaceX doesn't exist in a vacuum. And Falcon Heavy's story isn't just about ambition. It's about changing the rules of the space race. The space race of the 1960s was defined by flags, fears, and firsts. Today's race is about access, economics, and endurance. And SpaceX, powered by Falcon Heavy, redrew the starting line. Before Falcon Heavy, deep space was the exclusive playground of the national space agencies. NASA, Roscosmos, ESA, launching a heavy payload meant years of paperwork, billions in funding, and one chance at success. Then came a private company, offering government-grade lift at a fraction of the cost. Falcon Heavy slashed the price per kilogram to orbit. It delivered big payloads like the military's X-37B spaceplane or NASA's Psyche probe without requiring a bespoke government launcher. It also changed how space was perceived. No longer the domain of only governments or billionaires, Falcon Heavy opened the conversation about commercial Mars missions, modular space stations, and lunar bases supplied by private rockets. NASA took notice. So did China, so did Europe, even India. The Artemis Accords, joint lunar exploration pacts, and a boom in international launch activity all followed a pattern. Cheaper access meant more players. And Falcon Heavy, even if briefly, was the model. The rocket didn't just launch satellites. It launched a new era where space isn't just an achievement, it's an industry. But even industries move fast. And no rocket, no matter how revolutionary, can lead forever. For all its power, Falcon Heavy was never the endgame. From the beginning, Elon Musk saw it as a stepping stone, a proof of concept, an interim tool to finance the real dream, Starship. Falcon Heavy, while groundbreaking, had limits. It required side boosters that needed complex landing coordination, its upper stage wasn't reusable, and its payload fairing, while massive, still capped its Mars ambitions. While Starship, on the other hand, is SpaceX's towering, fully reusable stainless steel colossus. While Falcon Heavy could fit 64 tons of LEO, Starship aims for 150, and it can refuel in orbit. That's not an upgrade, it's an evolution. Starship is the vehicle that Musk believes will make humans a multiplanetary species. It's what he wants to land on Mars. It's what NASA has chosen to return astronauts to the moon. And it's what the Department of Defense is eyeing for point-to-point orbital logistics. So where does that leave Falcon Heavy? Still flying? Still reliable? Still powerful? But increasingly transitional. Like the Saturn 1B after Saturn V, or the Space Shuttle's final missions before Dragon, Falcon Heavy changed what was possible. But Starship aims to change what is inevitable. And if Starship does succeed, it won't just render Falcon Heavy obsolete, it might render every launch vehicle before it irrelevant. In the grand arc of space history, Falcon Heavy stands tall, not for how long it flew, but for what it made possible. It proved the skeptics wrong. It brought back the drama of dual rockets landing. It challenged entrenched aerospace giants, and it reminded the world that space could still surprise us. It didn't just launch satellites, it launched ideas. Ideas like, maybe heavy lift could be affordable, maybe rockets didn't need to be disposable, maybe space wasn't just the realm of governments, but of engineers with enough guts to weld together dreams in a Boca Chica tent. It forced a generation of space players to rethink everything. Falcon Heavy triggered a chain reaction in the aerospace world. Without it, there is no Starship. Without it, NASA doesn't bet on commercial partnerships the same way. Without it, The new space race looks very different. Its story is still being written. There are missions left in the manifest. Contracts are still being signed. But in the eyes of history, Falcon Heavy will always be remembered as the rocket that punched a hole through doubt and made room for what comes next. It didn't land on the moon, but it helped aim us there, and that changes everything. If this deep dive gave you a new appreciation for the rocket that changed the rules, give it a like, share it with your crew, and subscribe for more cinematic breakdowns of space innovation. We're just getting started. The skies are changing faster than ever. Follow Project Aerospace to keep up with the latest in defense and aviation. The next breakthrough is already on the radar.